Hi everyone, this is Sairaj from AIML and my concept video topic is N properties of NPN transistor in a active region. Let's enter into topic. First, introduction. A transistor is a three-terminal electronic device where small current at one terminal is used to control large current at another terminal. Transistors are mainly used for the amplification of the electronic signals. Before going to the topic, what is meant by transistor? It is a three-terminal electronic device and it is used to control the small current at one terminal and used to control large amount of current at another terminal. And it has three terminals that are the transistor comes with three terminals called emitter, base, and collector, which are used for the external connections with electronic circuits. These are used to connect the circuit. This is called electronic device as it has the three terminals. It is used to connect to the other electronic circuits. And in this emitter, and the NPN transistors comes with three layers, that is two n-dope layers and one p-dope layer. The p-dope layer is sandwiched between the two n-doped layers. Means as we have topic is NPN transistor, and NPN transistor means two n-type materials and one p-type material. That is the p-type material is sandwiched between the two n-type materials. These n-type materials and p-type materials are the semiconductor materials. Here you can see here NPN. This P is sandwiched between this N and two ends. This P is sandwiched between the two ends, and this is the general construction. And we can see this is the electrical symbol. And in NPN transistor, conduction is carried out by both charge carriers, that is electrons and holes. However, electrons are major charge carriers in NPN transistor. Mainly in n-type material, the majority carriers are electrons and minority carriers are holes. In p-type material, the majority carriers are holes and the minority carriers are electrons. This is the main thing we have to remember. And we have four type of modes, that is in active regions and cutoff mode and saturation mode and reverse active mode. Now we are going to discuss in that is active region. In active region of NPN transistor, active mode is used for amplification of the electronic signal where small current at the base terminal is given being amplified at the collector terminal. Let's take the example of common emitter. Here we will give the input current to the base terminal and the output current is collector terminal, and the base terminal is responsible for the transistor action which controls the number of main charge carriers and electrons in case of NPN transistors and holes in case of PNP transistor. As we have two n-type materials, so the major carriers are the electrons only, and we have only one p-type material, that is the base. In base, this is also lightly doped. Doped means there are less number of holes also, and there are many number of electrons, and that is majority carriers are electron. In case of NPN transistor, in case of PNP transistor, the holes are majority carriers and the P and electrons are minority carriers, and the flowing through it and draw a small current when a proper bias voltage is applied. Here you can see this is the symbol, this is the emitter, this is the base terminal, and this is the collector terminal. Let's take example of common emitter. This is common emitter diagram. Here you can see the input current is IB, that is base current, and output current is IC, that is collector current, and this is going to ground, and that is common for both IB and IC. So we will call it as common emitter current. And the input voltage is IBE and output voltage is ICE. The circuit diagram of the NPN transistor is shown in the figure. The forward bias is applied across the emitter base junction and the reverse bias is applied across the collector base junction. The forward bias voltage is VEB is small as compared to reverse bias voltage VCB. Here, if we want to make this circuit in active region to act as the active region, so we have to give this emitter current and emitter base junction should be in the forward bias, and collector base junction is the reverse bias. So then only it will act as the in active region, and we will and it will perform as the amplifier. The emitter of the NPN transistor is heavily doped. When the forward bias is applied across the emitter, the majority charge carriers move towards the base. This causes the emitter current, i.e., the electrons enters into the p-type material and combines with the hole. Whenever we are giving the forward bias to the emitter base junction and reverse bias to the collector base junction, that means here N we are taking NPN transistor, and N the majority carriers are electron, so we have to give the negative terminal to the N type, that is common emitter base junction, and we have to give the forward bias reverse bias to the collector base junction. That means N type carriers, majority carriers are electrons, so reverse bias means we have to give the plus polarity, this plus polarity to this N type material for collector base junction. Then it will works when we are giving the forward bias to the emitter base junction. The electrons in the N type material, that is majority carriers in this N type material, move toward the collector side in this emitter, and electrons move from collector side, because in this some holes are present. Some of the electrons in this which are transferring from emitter to collector, it will combine with the holes in this p type, and it will act as, and it will formed as electron hole pair current, that is IB current, and another which are there electrons will enter into the IC current. As this is lightly doped, it will enter from emitter to collector, and the here the input current is IE and the output current is collector current, and the input voltage is VEB and the output voltage is VCB. The emitter of the NPN transistor is heavily doped. When the forward bias is applied across the emitter, the majority charge carriers moves from this base junction towards the collector junction. Here, the base of the NPN transistor is lightly doped, due to which only a few electrons are combined and remaining constitute the base current. As we have discussed earlier, few of the electrons combines with the holes in the p-type material, and that hole electron hole pair is called the IB current, and the base current enters into the collector region. The reverse bias potential of the collector region applies the high attractive force on the electrons reaching the collector junction, thus attract or collect the electrons at the collector. The whole of the emitter current is entered into the base, thus we can say that the emitter current is the sum of the collector and the base current. In formula, IE equal to IB plus IC. Emitter current equal to sum of the base current and collector current. Let's see the output characteristics of the NPN transistor. The family of output characteristics curves of a bipolar transistor is given below. The curve shows the relation between the collector current and the collector emitter voltage with the varying of base current. Varying of base current, we know that the transistor is on only when at least a small amount of current and small amount of voltage is applied at base terminal related to emitter. Otherwise, the transistor is in off state. As we have discussed this common emitter, so we have the input current is IB current and the output current is IC current. whenever we apply some voltage or current, and then only it works as the transistor, then only it works in on state, otherwise it won't, its state is off. So this is out. In this output characteristics, we will take output voltage and output current. That is, in common emitter, the output voltage is what? VCE. That is emitter current, emitter collector voltage, and IC, output current, is collector current. And we are making the constant of IB current, that is base current, input current. So we will get this curve. This is the active region. This is the Q point. Whenever we are applying some voltage, whenever we are getting some output voltage and output current, if we draw and if we plot the values, then we will get the input current as the IB of some value. This is the cutoff region. This is the load line. The region above the load line is the active region. The common emitter configuration characteristics curves are used to calculate the collector current when the collector voltage and base current is given. The load line is used to determine the Q point in the graph. The slope of the load line is equal to the reciprocal of the load line, that is minus 1 by RL. If we go with the input current, we will take the input voltage and input current, and we will calculate the output current, that is IC. So this is the characteristics of region. Whenever we want to make the transistor in active region, we have to give the emitter base junction as the forward bias, and we have to give the collector base junction as the reverse bias. Then only it works as the active region. Then only it works as the amplifier. This is the main thing we have to remember. And thank you.